Так. So yes, I'll go today just to go brief the tasks and discuss how to solve them. And let's start from the seventh one because it was a tricky one. This one. So if you know the property of regular, the general order is regular quadrilateral pyramid. So I told you for edges from the base, all edges are equal about quadrilateral. But about regular, so also lateral edges, these edges should be equal. In this case, you can say that by contradiction is wrong, because if you try to find the SA and SC, for instance, in our case, you can see that the length of it will be different. So the length of this will be so it's 36, 4, 9. And there it will be 1 plus 16 plus 4. We can see that it's, we even don't need to calculate, we can see that it's wrong. So we can write. So by contradictory, it's wrong. We cannot solve this task. The task is wrong. 6 out of 6 because you prove that it cannot be solved. But if you are dummy like me and you don't know about this property, you can start to solve this task. Of course, I think you agree that the most interesting part is the first one, because if you find all vertices in this case, or other tasks are just common task from this type of task. So we won't cover it, because pyramid, you can Google it, this equation, you already know it from internet. This and this one, you also can Google it will be the first, how to say, actually the distance, you know the equations. Now, because it was the third, if not mistaken, yes, third one, the third equation from my file, fourth one from my slides, that when we have this formula for distances, and one of them was distances from point to plane. And this is between two lines, actually you just need to take 2 points and connect them. Which is not a big problem. About the A1. I prepared MATLAB code, and also I prepared the GeoGebra. So, in GeoGebra, it looks like this. It's fine. Okay. So actually, first of all, you need to get what's going on there. And as Roma or Toma, I forgot Toma probably, yeah, Toma mentioned that we have infinite number of solutions. Why? Because if our lateral edges can be changed, in this case, it also will rotate. So it should be like this. So I made a variable angle, and we can rotate it. Of course, in some cases we have, let me say, a singularity. I mean that when it will become, it will be reduced to the line, I mean to the plane, not to the pyramid. And you can find it, but for our case, now we are not interested in it. Because of course it's more complicated. In our case, we're interested how to receive such equation to find all possible solutions for B and for D. How can we solve it? I am sure that there are several approaches, but I decided that the most classical one is working with bases. So actually, in this case, I widely use change the basis approach. How it look like? So the main goal is to obtain the new basis and after this do something with it. Roughly speaking, we can take a basis, so we have point, we have diagonal.
Can you share it?
Yeah, I will do it. As I told you, after the class I will make a nice presentation and send it with the links. So AC our diagonal and it's S. We need to find such 2 points which make us a square like this, B and C. My assumption that the D, okay, thanks. The easiest way to make such, say, bases which will look like this. So X will be according to one point, B to the other point, and the last one, you may see it's perpendicular to AC. Why this way? Because after this, actually, yes, we need to make a circle. How can we do it? We can easily rotate our bases according to the center of rotation. Our center of rotation is diagonal. And each time we'll receive our needed points. So we just need to rotate our, let's say, bases and we'll receive all needed points. This was my assumption and my goal. I wrote some coordinates after this. First my way was to find some particular, so we need to receive 3 vectors. First of all, I decided, okay, let's make a plane, take a plane. We have 3 points. We know that one plane because it's triangle. And I found this let's say equation of the plane. We know it because actually we have determinant of these 3 points. We have this formula. I did it. And I received 28x minus 14z. After this I took a normal. Of course we need to normalize all our vectors. Why? Because in this case we won't have any problem with values later. So I just took ABC from it and received this ACS. Can you see? After this, I decided to find the other vector. It's cross product between AC and this normal one. So normal there, this one there. What we will find? We'll find normal to this line. And it will be our cross product, yes. And the last one, it will be AC norm, it's this line. So now what we will have? This one, AC. How can we find if we know equation of this line? Because we have 2 points, we can find the equation of this line. And we just need to ABC, take AB. We take a normal to this guy and normal in the plane. I mean, like this. But for us, it's not the best place because we cannot work with it. So we need to, let me say, rotate. So we need, now we have diagonal and something else. We need to rotate on 145 degree. Let me say like this too. And we'll receive our needed coordinates. How I did it? So I took AC norm plus this normal. How can we find this? In our case, we are not operating with 45 degrees. I'm operating with vectors. Even though the 2 vectors are equal, because I normalize them, the summarize will provide us the solution. And also I normalize it, so it would be like this. And receive needed vector. So yes, we know that 45 degrees, and I could just rotate, but for me it was easier just to find the summarization. After this, I took a cross product because I was too lazy. Minus the products. What does it mean? I find this one. We know that between this one and this one should be 90 degrees.
Maybe 45.
Because what?
45? No.
Between one rhomb, AD
and AB.
AD and AB.
Yeah.
So I just took cross product and received this solution. Yes, of course you can do it in different manner. You cannot not to, either make rotation around 90 degrees or whatever you like. In my case, I just find the cross product. And took the last one, Z. It was this one. I mean, perpendicular to AC. The most hysterical part there is to find transformation matrix. And there you might make a mistake. First of all, we need to open the Grodetsky slides where he explained how to go from one basis to another basis. It was new basis equal to old basis on some transformation matrix. Very interesting is this guy. So, to sum up, what we have AB in new basis. What it will be? It will be, so if we decide that, actually I draw it differently according to my one, because B was on x-axis. Here I draw it as a y-axis. Let's change it to consistency. AB it will be AC divided by square of 2, 0, 0. Did you get why it's like this? Because it's square, we know only the AC length. If we know this one, we can find other base edges. AD, what it will be? Timo.
Maybe 0, AC over square root of 2.
Yes.
And 0. Yes.
Yes. Correct. So, because our edges is our basis. Correct. So we need to know this formula because it will be our transformation from. What does that mean? New basis for us. New basis will be this one. We already received these three vectors because when we solved it, I mean when we discussed about it. So we know this fully. Old basis, what it will be? It's our Cartesian space. We already know it. So how to find this guy? Inverse, yes, we need to just put it there, so it will be, in our case we can actually say transpose, but okay, inverse, divided by new base. And we receive our transformation matrix. And make transform matrix, it's there. So inverse, identity matrix as I said, and our new vector. Boom, boom, boom. I make this variable, but the most interesting way there to, so first of all, let's discuss, we don't want to rotate anything now. We just want to find the one particular solution. What we need to do? We need to write, I'm doing there A, in my code it was H transform, let's use A. A multiply on AB new basis. Actually, it's a problem why I didn't use A, because A, we have A there. It can be. So by this AB D prime. That's it? Or we miss something? Telephone.
Transform matrix.
What we forget?
H is the transform matrix.
Shift what? Yes, because now we talk about the base actually in S. We need to put it in C plus A. Vector, it doesn't matter where the vector, because vector doesn't depend on the basis. But in our case, we want to find coordinates. It's the reason why we need to shift it to the basis. Okay, so using this one, and for AD, it will be the same. Now we are interested in rotation, because actually we have many solutions. There are plenty problems, but actually you also had all knowledge to solve this task. First of all, we need to understand where do we need to rotate. I mean, about around what? Because in our case, we are not rotating about some particular axis. We have some vector and we are rotating around it. Because we used to case when I explained about rotation matrix was Rx around 45 degrees. So it means that we have two x-axis and rotate around this. In our case, we don't have x, we have some vector. How to operate with it? There are two possible solutions. One of them, Google it, because actually there is some equation exists, even in Wikipedia, how to find the rotation around some particular axis. Or you can find it using some knowledge and understand how it should work. Because what does it mean rotating in our case? Rotation is, it's let's say circle. So we can rewrite it in such manner. I plus, so we want to, first of all, we need to find this vector in new basis. So our vector should be, I wrote it 1, 1, y. We have one basis on I and x-axis. And we just try to find the intersection of them. So I plus, I wrote it there. I wrote it in skew symmetric form. We discussed how to do it. It was on the second class, if not mistaken. So it will be sine our angle plus like this. This equation appeared because you can try to rewrite it in such manner that actually it's better to explain when we have talked about affine transformation. Okay, let's discuss how to solve it differently, not using straightforward approach. In our case, I use just straightforward because I know this equation, know that it exists. Let's assume that you don't know that you can find vector, such matrix around which when we can rotate our this vector. How could you solve it? So you have some basis and you want to rotate around some particular vector. How you can do it?
maybe we can make an equation of circle, and the midpoint of this circle will be our basis, and then find the vector rotated.
How? Could you try to do it?
Using some equation.
Guys, try to think. You can solve this task.
Yes. Create new bases, and one of each axis should be this vector, rotate around over this vector, and again change bases to make it like our own.
Yes. So, how it works? You need to take these bases, rotate for 45 degrees, because in this case, one of your axes will be on this on this line. After this, using a variable angle in our case, or it will be tau now because it should be parameter. You rotate around needed axis, and after this, you again you use, let's say, previous transform, so it will be in our case RZ45 transpose Rx theta RZ45. So yes, brilliant. Idea there why we are plotting in this manner but not vice versa, because we are talking about fixed angles. Actually, we didn't cover it, and you don't need it because you may see he said it without knowing this knowledge. But actually, we have Euler angles and fixed angles. Fixed angles, when we rotate, so Euler angles, we have some particular angle. We rotate it. After this, our new angle will be according to the new basis, like this. But in this case, we use like rotate, but we rotating around the fixed angle, so original one, and we can return it to initial position. The difference between Euler angles and fixed angles that you need to write it in different manner. So you can find this precise solution if you write from left to right. It will be Euler angles. From right to left, it will be fixed angles. Actually, you don't need it in not robotics applications most of the time. Maybe in some data science part, but I'm not really expert in this part. So yes. Or you can receive my equation, despite it, where we need to put it there. So let's call it rod. Where do we need to put it in such equation? What? There, 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 there. Where?
First.
Сюда.
Yes.
Other ideas?
In front of H and in front of A, maybe.
Actually, I made this mistake first time when I tried to code it, but I found it faster. Of course, I also put rotation there, and it won't work. Let's think why. Because in my case, I saw, okay, I had a picture, and I rotated, and I see that it doesn't work like needed. But I found fast where I need to put it. How? Actually, this task is complicated because you need to understand the nature of change of the basis. It is the problem why it's wrong. See, here we are operating with new basis. Am I right? It's transformation from new basis to old one. When you put rotation there, what is it? We are rotating what one? We are rotating the new basis. So if we are put there, so we are trying to rotate our old basis in a new manner. So we have such vector. We rotated new basis. We won't change the basis. Actually, we change, but our equation just rotates. So we put rotation there, and after this we transform our new matrix in that manner. Because rotation won't change our, how to say, length, our angles between bases. We just change. I mean, we just change the orientation of this vector. So transformation matrix will be correct. And you may see it there. So D, rod 1, H transform. Also, how you can check that it works? First of all, we need to check that our dot product between two, let's say, two edges will always be the same. We need to have 90 degrees. It's one of our possible tests. Second one, the length shouldn't be changed. It's the reason why I took AD new distance, because we need to change the previous one and new one. So AD and new. I calculated there because it was easier for me, and I just put it to GeoGebra there. I agree that this task was a bit overkill for midterm, and thanks to our professor that he decided to put to everyone the max score for this task. But despite it, if I talk about algorithm, it's a solvable task for you. Of course, in this case, you need to know how to operate with angles correctly, with bases. Despite it, you can solve it. Any questions regarding to this task? After this, of course, we find all points and we can find volumes, whatever you like, because in this case it just became, how to say, task for geometry, I mean from your school, high school, because you need to operate with geometry.
Why in place we have a square?
What do you mean?
Because in the task,
it's regular quadrilateral. All edges should be equal. The base angles and angles too. Lateral edges, lateral angles. All this should be
about angles.
Let's Google regular. Square pyramid, blah blah blah. Regular, irregular pyramid. In this case, if you're considering that you don't have, how to say, if you want to even make the more generalized task, and consider that you don't have angle, I mean, you don't in this case you don't have any possible ways to solve it. You don't have enough equations because in this case you don't know anything about angle, anything about length. In this case you don't have enough I mean, let's say material to solve it. In this case you have, if you consider that our lateral edges can be different, but our base are considered, and I considered explicitly when I wrote in brackets. So this is regular pyramid. Base is regular. Actually, it's very nice site to read this part because I also put pictures from it after the first test. That probably you remember, because some of you didn't know about edges and vertices. It was from this site. What? Настя Пузанкова should put it in her. And our groups don't have this. Okay, shit happens. Okay. I gave the link to other groups, but not to ours. Yeah, boy. Okay, so shit happens. I don't see any reason to give them 1.5 class left. They can watch video. Okay. So we discussed about the first task. It's just skipping task. The algorithm again. We need to find in some form this guy We had a general form, we need to obtain the canonical form, for instance. And after this, we need to use equation. And hooray. Bam. What about second task?
This task is just from tutorial.
Actually, yes, because it's a results task.
Just the same.
So, okay, so first of all, if you want to find the particular solution of the tutorial, and you will get how to solve this. In our case, so I especially put, actually it was result task, but I especially explained what it means orthocenter, because for me, I also had, okay, what's the difference between centroid and orthocenter? So I decided to write it explicitly, because it can be, yes. So you draw this picture, you find some particular point. Sounds like we're from the geometry, 9th class, 9th grade, I mean. We have this point and some points. So how you solve this task? How did you solve this task?
We can make a system of equations using cross product.
Dot product.
Dot product, yeah. And the dot product will be 0 with some altitude and the base of triangle.
So
I'm inside.
So what precise vectors? I mean, let's write A, B, C, I don't know, D, and how you took it. So
CD should be perpendicular to AB. Therefore, cross product between these two vectors will be 0. And this is our first equation. CD and AB. Dot product, yeah.
Dot product, yes. And you wrote it 3 times?
Yeah.
2 times.
Not 2 times, yes, because we need to find, so we have two, how to say, we have two variables, 2 equations, because x, y. And we solve this task, and after this we can do like this. Yeah, boy. 4 points in 1 minute. Okay, this one. This task was not so easy. It was Vladimir Ivanov's task. Actually, about rhombus, it was also Vladimir Ivanov's, but I agree that it's a good task. Today I tried to find the solution for the rhombus from book, but I understood that I had my original task, but he said, Oleg, it's too difficult task, to take other one, and he gave me this rhombus. Okay. First of all, we need to solve A. I hope, but I understood that some of you forget how to multiply matrices. Tick, 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 yes. Tick, tick, tick. Okay, you did it. Whatever you can find either, as I wrote it, no solutions, infinite number of solutions, or one particular solution. In different variants, it was different. We are not interested in it. Why? Because we are interested in B task. Because actually the first one is straightforward. B, most of you, what is it, how to solve this, and blah, blah, blah. How can we easily draw? First of all, we need to get what we need to draw. What we need to draw?
Line of intersection.
We need to find. We need to draw planes. Yes, because we have the x, y, z. Originally, it wasn't explicitly explained, and I also didn't get what we need to draw. It's the reason that we try to explain explicitly. I just give you inside information how we are making tasks. Okay, so actually a x, y, z equal to b. We can rewrite it in ax plus by plus c z minus, in our case, b, it will be d minus b equal to 0.
Yes.
So we receive general form. How can we draw it easily? What? Intersection? In sections. Yes. I hope I already. No, I didn't put it. So in sections, when we make it like x something there, something there, equal to 1. Actually, we need to divide by d, and we will receive that it will be a d, b d, c d. If not mistaken, it should be also be some minus there.
In this
Yes, minus.
case, minus.
Yes, like this. I know how to do it. Okay, so you redraw it. So you need to take all, A, B, we have free plane there. And we need to draw it there, like this. And why I told you that it helps us to understand what's going on. Because, for instance, we don't have any solutions. It means that they are not intersecting between each other. And you draw it in some manner, I don't know, it will be like this, for instance. They're not intersecting, so we don't have any solutions. If it intersection in line, what it will be? Infinite number of solutions. Because actually it looks like when we try to find line in space, you have infinite number of solutions when they intersect between each other. What? Yes, because some people didn't get how to draw it. And the last one, when it's intersecting one point, in this case only one particular solution. Is it good numbers or no for drawing?
Which number?
So A, B, C, and D. No?
I think it's better to draw into the space, into the space.
What do you mean?
It's hard to draw 3D and
But you want to say that it's better to make this task into D instead of 3D.
maybe harder for them to do.
Into
To
D?
draw. Yeah, in order to draw.
Draw into D? Why? If it will be either the line, either the plane. You have only two possible ways, because in 2D, in this case, you just took one plane and you actually make section. So разрез and draw it. So it seems that in 3D it's not a big problem. Of course, if you don't have any rulers and this particular instruments, it will be more complicated for you.
Very cool to
Yeah, I know. Or credit card. But the problem why I said you explicitly, because of my task with rhombus. So about this one, it's a common task from this book which we use to give you home tasks. So I will provide you a solution for this from this book. It seems not very difficult task.
Super easy.
Super easy.
One formula.
One formula, okay. So, but actually, yes, because we had the equation from plane to plane. I also put it in slides. This one. You can solve it in two manners. You can solve if you have cells in your sheet.
Many book.
Yes, I did it using this one. Why? Because the one point, actually, I changed only this point between different variants. The difference would be only in M, because so I wanted that you will solve this task easily. And the difference was with -1, 2, 2, -1. I just changed the, let's say, minus plus. We took some point M. After this, I said, okay, let's try to draw this one, 120 degree. What is it? If you know how to draw angles in your, let's say, in your notes, yes, it's not mistaken, 3 points right, 2 points up. It will be 30 degree. And you draw in different manner the same. And you receive 120 degree. And this number equal rhombus equal to 2, if not mistaken, at least when I draw it at my handwriting, I receive that it will be also in points. So it will be 1 point, another point. Could you check it? So actually, you may either draw this task and just receive coordinates because of drawing, and put it and solve the task. It's one of the possible solutions. The second one, how you did it?
Using sine, cosine, or something like that.
How you solve this task? Vova. Did you solve this task?
No.
So, Toma.
I find 4 points and
How did you do it?
sinus 60 degree and cosinus 60 degree.
So you just assume that okay, we draw some. Actually, yes, our goal to find, if we find each point, in this case, we'll solve the task. Because if we have 2 points, we can easily obtain the equation of line.
We can write, we know diagonals. We can say, for example, we know point M. We can say, so we know x coordinates of B and D. And we can create a parameter y for their coordinates.
So we want to say that we know B and D.
We know B and D x coordinate.
Actually, no coordinate for this guy too.
Yeah.
Because in this case, yes, sine cosine. Because we know that it should be 30 degree. And it's written that it's parallel to horizontal line. And in some tasks it was parallel to vertical line. Yes. It was the difference. Vertical, horizontal line and the coordinates. And you just need to operate with coordinates. Boom. Who didn't get how to solve this task? Because it seems like what to do. You didn't get.
Yeah.
Okay.
I have a question.
Yes.
Is it correct that in all variants there will be horizontal axis parallel to horizontal axis?
No, I changed in some variants it was vertical, parallel to vertical lines.
Okay, thank you.
I made only M, I changed M and I changed the vertical. That's it. So we discussed about this, boom. Настя Puzankov's task. Who can understand where she drew it? What's the application did she use?
For extra point?
What?
For extra point?
No. Apple. She just drew it in Apple. Actually, it's interesting to understand where some people make his she's presentations, drawings. It's just interesting for me to do it. For instance, you can easily understand when the person make slides in LaTeX because they have some particular structure. Even this because these lines look like that it was something in Apple. It can help you to understand how it was made and use this application if you like this solution. Okay, how to solve this task? Actually, the difference between this task was only from what basis to what basis. So, how can we solve this task?
I guess that I did mistake.
Roma. Did you solve this task? So could you explain?
Can I solve?
No, I want Roma. He's better than you for today.
I use 14. From x1 to x, no, x1 to x2. -1, -2, -1, negative. Up to 2 minus 2.
So you took a basis, you correctly get a basis.
Um,
What task are you solving? From the whiteboard or your own task? I mean, now are you solving your task or task on the whiteboard?
on one board.
Okay.
One. And we write the formula. Okay. It's magic formula. We should find this.
What is V1?
Some points in in surface. Yeah.
And you want to say that V2 will provide you a transformation matrix.
No, we should V2 is equal and it is transformation and shift.
How could you check the solution?
I take one point and calculate to check.
So, for instance, you took, let's solve this task, I think we have time.
Okay.
Yes. Problem of tall people.
Minus 2, 6. Yes. Minus 2. 5, 2, 6, 8, 8. 4 plus 2 and minus 4 plus 6. One. Minus 1 over 4.
And let's check. Take 0, 0 in origin.
0, 0.
Okay. So we put it in origin. So we need to change the translation matrix is correct.
What is V1 and V2?
It is V1. It is point in basis 1. V2. It is point in base 2.
So you want to say me that we have V1, so we move from 1 to 2. Okay. So what is the difference between origin from this to this? 2, 2, 0. Can you see 2, 0 there?
But 2, 0 in this order. But original one. In base 2, it is not 2, 0.
Ah, you want to say okay. You want to check according to this one because
Yes. Because all of this is equal. We in this in 0. Yes. In this base. Okay.
Okay, if I want to check, okay, the sub question, okay, how can we check it if I want to check it according to the Cartesian space? I mean, this one, what we need to do? Guys, how can I check it if I want to check it in Cartesian space, not according to this one?
Okay.
That I solved it correctly.
Okay. We may take this point because this point is minus 1 and minus 1 and 1 in this base.
Actually,
It is easy to check.
one of the possible ways is just make one extra transformation to this one to this. So you can check from this to this if you make transformation from this to this.
Yes.
In this case, you can check it because you will. It's as I wrote it on our previous classes when. So I mean when we have homogeneous matrices and we just wrote like this. But because how? So you told me that you check it. How you check it?
I take this point. In base 1 it is minus 1 and 1. In base 2 it is minus 1 and 0. And I calculate and it is right. It is right.
Does anybody solve it in different manner? You solve the same.
Okay. Am I?
Yeah, sure.
In this case, we can actually just sometimes we can not calculate numbers, just to try different numbers actually. Transformation.
very nice idea to use brute force, I think, during the midterm. But if you don't have any other solutions, I like this way. Okay. So again for you, because it seems you didn't get. They wrote, as you remember, that the problem is that vector cannot. So coordinates will change, but vector itself not. So we take some vector. It will have this precise vector will be the same for one coordinate frame and for another coordinate frame. It's the reason why we make it equal. But our coordinates will be different. And we want to find this transformation because we know to have for one vector, and we know to have for another vector. And we try just to summarize, multiply them, and receive the solution.
Do it exactly, but I was not sure about distribution law. It works like that, yes, when we just multiply inverse matrix on origin first, then okay, it's the third line from the top.
Yeah, it works because when you multiply matrix by v1, you will receive a vector. You will sum up two vectors. You will have one vector, and then you can multiply a vector, a matrix on vector.
Okay.
Works.
Because I was not sure that it's correct, but I do it.
Okay. I did, yes. And the last one, we discussed it.
And what's
Yes.
the answer? But this is sum of two matrices. This is not one matrix. Matrix.
See about so transformation matrix. In general, it's a bit say. If you're talking in robotic, when I explain the homogeneous matrix, you don't have any problem because the homogeneous matrix you just put this one there and this one there. Transformation matrix. It's called transformation matrix in general.
Okay.
So what did you do? So actually you can say that can it help us to transform from one matrix to another matrix? Yes, it is.
Yes.
He didn't put it in one matrix. I don't see. Yes, if we are talking about efficient multiplications and so on during our computations in computer, yes, it's not very nice idea. It's the reason why I explained you homogeneous. Yes, you didn't get it according to feedback, and probably next time I need to make the slides in different manner, maybe spend more time on it. But if you spend more time after the class, probably you will get why it appeared and how to operate with it. So it seems like this. Synthesis I also explained. If I were you, how I solved this task. It seems that's it. On next class we will learn conic sections and so on. It's some pictures like this. It will be. We'll have some fancy names like hyperboloid, conic, blah blah blah, because a lot of yes. It seems I will give you some extra material for this guy from game development. Okay. See you next time.